My name is George Hatch. I am a Senior Technical Specialist for Autodesk. I do focus on the East Coast of the United States in Canada, and I focus primarily on our E&I products, which is engineering, natural resources, and infrastructure. So most of the civil engineering and structural engineering products. However, my degree is in architecture and industry experiences in GIS and civil engineering. I also have some CFD, simulation and analysis background. So I'm really kind of uniquely placed here to talk to you about multiple different solutions around reality capture. Because let's face it, every project exists somewhere, and that's what we're going to talk about is the existence of reality around your projects. Where are your projects? Whether you're working on buildings, bridges, utilities, or roadways, each one of these individual project types, of course, exists somewhere. It doesn't exist in space. It exists in the context of its surrounding. And this is really important for us to, of course, understand. Now, all of us understand this fact. It's kind of a silly point to bring up even. Except for the fact that most of us start our projects just like this. We start our projects in a design application with a blank screen. I've worked on many different types of projects, through my career. Most of my civil projects, we would start with some sort of base survey. But even before the survey was conducted, we would usually still have a base screen, and we would start from there. And the reality is we're designing around something most of the time. So why not start our project with a context, like a scan? Maybe it's a laser scan. Maybe it's a model that's been built from photos, and we'll talk about that in a moment. But the whole point of reality capture is to capture the existence of the reality around your project so that you're better informed and can move forward with the design. It creates a much more accurate, much more informed design right from the beginning of your project. Now, there's different types of scanning equipment out there. There's airborne laser scanning, mobile scanning, handheld devices, and the ability to convert photos to 3D models, and we're going to talk about those different forms and what they look like. I will just say this: when it comes to airborne laser scanning, the level of detail is not necessarily going to be a level of survey grade detail. You won't have as many points in an area as you would with a mobile solution. Handheld scanners I don't know if you can see my cursor here, but a handheld scanner like a Faro arm is great for small scale building a model, but not necessarily for building an entire scan of a building, of course. And then photogrammetry, or the ability to take photos and build models from those photos, is amazing when you're starting a project, and it has its own level of accuracy. So understanding these different forms and the level of accuracy and when to use these different forms of scanning is really important. You need to understand that. And we can get into a lot more detail, but since we only have a half an hour, I probably won't get into too much detail there. So let's talk about the cost of data. When you're starting to talk about laser scanning, over the years, traditionally, we've been looking at, laser scanners in the 120K mark or higher. That was your entry-level scanner. These days, the cost of scanning has gone considerably. Now, the numbers, are plus or minus probably 5K, 10K. But when you look at the difference in the price of, these two specific types of scanners, both Leica, Faro, Topcon, have all brought the cost of their scanning down considerably. It means that, Joe engineers, a small firm, can start to get into this space at a cost that makes a little bit more sense to them. Now, I am going to throw this up there. You know, we've talked about free scan data, and this is where my caveat on accuracy comes into play. Most of you may or may not be familiar with GIS. Now, most states provide, I happen to have PASA, which is Pennsylvania's GIS site, and Rhode Island GIS here, Mass GIS, New York GIS. There's a ton, every state likely has their own GIS portal, but many times states are going to fly the state, they'll pay to have the state flown, and they'll provide laser scan data, aerial laser scan data for consumption for your projects. Now, keep in mind, this is not going to be something that will replace a traditional survey or a more accurate scan, as Joe was talking about earlier, but it is something that we can utilize at the beginning of a project, and it's free. That's the best part, that it's free. And we have tools here at Autodesk I'm going to talk about in a moment that will help you consume that free data. But the overall idea here is that the cost of data and the cost of entry into scanning and the ability to consume scanned data is dropped dramatically. So let's talk about the Autodesk Recap product line. We do have kind of three different buckets here. We have Autodesk Recap, which is the product that ships with our suite. You can also download it from our website. And then we have Recap Pro, and then Recap 360. And we'll talk about some of the differences in these three different specific products, but all of them have to do with reality capture. Recap allows us to do edit, visualize our scans, or maybe it was a 360 photo model that we've built, and we bring that into Recap and make edits to the point clouds. And it also converts those point clouds into a format that can be consumed in our hero products like Civil 3D or Revit or Navisworks. We also have, you know, sorry, did somebody need to say something? I just had a feedback, I guess, on my end. No worries. We also have Recap Pro. Recap Pro allows us to do targetless scan-to-scan registration. So rapid field data preparation, a lot of customers that are using our targetless registration are doing their registration in the field. This is a big shift in the way that we do scanning, and there are workflows that can be very effective. Also tying that survey data, the scan data, into survey control. With Recap 360, we have the ability to create photos from, create 3D models from photos, as well as sharing those scans with people via the cloud. Instead of sending an email, why not just send a link and they can download via the cloud and possibly even view via the cloud. So let's jump into Recap on its own. Recap is a product that allows us to consume point cloud data that has already been processed. What I mean by that is that it's already been cleaned up, it's already been stitched together, meaning all the different scan locations have been stitched together, and you have one single scan or a combination of scans already aligned. In Recap, though, we can go through, of course, we can visualize, as you're seeing here, we can visualize fly-throughs of the model and the scan data, and then we can get into making edits as well. When we talk about making edits to the point cloud, in Recap, we have the ability here to isolate out certain points using different tools. Like you can see here, we have bounding boxes. We can make selections by just circling a ton of points and then breaking them into different regions. You'll see here that there's a tank that needs to be, basically replaced, and we can remove the physical points from the recap model inside of recap and then utilize that scan data inside of a Hero application. You'll see that workflow in just a bit. So let's talk about our ability to absorb points into recap. Over the years, and Joe kind of touched on this, there is a ton of data inside of these scans. In fact, when I say a ton, we were talking about back in the 2013 product lines, we were talking about 2 billion points could be consumed inside of recap in our Hero products. Now in 2014 plus or 2015, we have the ability to consume 20 billion points. And that's a huge difference, of course, but even just consider 2 billion points seems like a really big number, and it is a really big number, but it is not uncommon to have a scan that hits 2 billion points, if not blows that out of the water. So it was really important as a company that we changed our model and continue to increase performance as the level of your data increases, as it will. The level of detail of your point cloud determines on how you set that up in the field, but at the end of the day, the more accurate and the more higher level of detail you have in your point cloud, of course, the better off you'll be in the end of a project for, whether it's construction verification or layout of a new design. For visual purposes, you can see that behind this, my call-outs here, graphics-wise, there's a pretty big difference. There's technically 3 images here broken up, one to the left, one down the center, and another to the right. It's the same scan data, but consumed in different releases of our product. And you can see originally we could really only consume black and white, low resolution, I'll say, scan data. And, we've progressed to be able to have color scan data at a better resolution. But as we progress to 2014 and 2015 products, our resolution and ability to consume that scan is much, much more clear. And the ability to stream the scan inside the product is much, much more capable as well. So let's jump to, we talked about point clouds and we talked about recap consuming point clouds. What are the different types of point clouds that recap can currently consume? Recap by itself, without Recap Pro for registration, we'll talk about in a moment, can consume these different point cloud formats. And the good news is that most of your scanners, no matter your manufacturer, will be able to at least export to this file format. This means that whether you've done the scan yourself or you're working with a third-party firm that is doing the scanning, they'll be able to provide recap-ready files so that you can do your editing and cleaning up. And maybe it's not editing or cleaning up, but you want to section up part of your project. You can do that all within Recap. As long as you have this file format, Recap will consume it. So let's talk about Recap Pro. Recap Pro targetless registration is a different workflow. And in the past, with traditional scanning, you would set up targets that look very similar to this. And the point is that you would set those targets up, and then when it was time to bring all of your different scans together or stitch them or build a single model from those multiple scans, you would basically use these targets to align your scans. And with Recap Pro, we basically remove that process, and you can use almost anything in your scans to use for targetless registration. This has several different benefits: less time on site for preparation, additional scans post-registration, meaning that in the traditional workflow, if I had done all my scans, taken down my targets, and gone back to the office, the ability to add more additional scans after the fact was a headache, to say the least. Now, this is not necessarily always going to be the case where you can always use targetless registration. There are vertical applications where this works really well. There are horizontal applications where the ability to have targets is going to make a little bit more sense for your workflow. But with Recap Pro's targetless registration, there really isn't anything out there that can compete with the way we set up our registration. You'll see that in just a little bit. And then we have advanced knowledge of the stand target placement that was required. You needed to know where to set up all of those different targets prior to doing your scanning. And like I said, adding targets or taking those targets down, going back to your office and realizing you need to put them back up, to add more scans was a problem. And then, of course, on-site registration. Right now, the workflow for most scanning firms is to do your scans out in the field, bring all those scans back, and then register in the office, which means that you don't know whether or not you needed more data until you're back in the office. Why not register on-site so that you know you have a full model before you pack your truck up for the day? So let's talk about targetless registration as a demonstration here. So the first thing you do in Recap Pro is you set up a project. And this project is a local project sitting on your desktop, which is important to know. Now, just in full disclosure, these scans that I used are low-resolution scans, and they're black and white. And I do that so that we can show kind of this process fast, meaning fast for the presentation. It's still fast in comparison to what the traditional workflow is, but you don't want to sit here for a minute while we see registrations process. So the next piece is that we choose our home scan. This is basically where we want to start stitching our models together. Now, the best part about Recap Pro is that you'll see here that we don't have to choose very specific targets, meaning we don't have to be really accurate. You see that I picked a trash can. Now, maybe the trash can isn't a good example because it could move technically, but then I'm going to pick the wall. I'm going to pick a wall in two similar locations in these two different scans that are side by side. And then I'm going to zoom in. I'm going to pick a column location, the bottom of a column location. And what happens is Recap then analyzes those two scans based on the points that I selected, and it will use those points as 3 points to align those two scans to. And then it forgets, once the scans are generally aligned, it forgets about those points and then uses common faces to align your scans. This is a really fast and accurate way to align multiple different scan locations. You see here I'm taking my third scan location and picking my common points. And it's nice to be able to have side-by-side views of your scans. You see that I picked a, just above a flange on one of those beams, and I'm going to pick another column. These are my, this is basically my review of those scans. As it processes, it's going to then register now this third scan into the overall model. Now I approved that scan, and I let this load. Now what it's doing in the background as I index my scans, you're going to see in a moment that it's going to index the scan. And yes, I do take a jump here, I think. I don't know that I let it play all the way through. Maybe I did. As it indexes these scans, what it's doing is it's setting the scan up so that we can consume it inside of the host application. If you've done scanning before, you've worked with point data in the past, when you try to bring that into AutoCAD or bring that into a product like Civil 3D or Revit, for instance, those point clouds really chugged, meaning they took forever to load, and it was really hard to manipulate and move around them. But with the recap engine inside those different products, which I'll talk about in a moment, it was really easy to manipulate and move around those 3D scans because of the process that we just went through. So let's move on to the recap product line, the recap engine. Right now, the recap engine sits within AutoCAD-based products, Navisworks, Revit, Inventor, Infraworks, Infraworks 360, which isn't listed here, but is basically the same as Infraworks as far as its engine's concerned. Civil 3D, Map 3D, Plant 3D, and 3ds Max. 3ds Max is an exciting new feature. But when we talk about integration into those different products, that is why recap really matters. We talk about a building renovation. You're looking here at a scan that is a scan of our tech shop in California, and simply adding some dimensions here. We can check dimensions. We can lay out walls. We can lay out floors, as you're seeing here. And what the key is we're actually using the scan as the base model. Now, there's a couple of different workflows. Joe showed some amazing examples of using the scan to build a Revit model. So you build a Revit model around that scan, use the scan as your base. And that is a workflow that absolutely makes a lot of sense in some situations. But in a scenario like this, where you don't necessarily need everything to be modeled, why not just use the scan as the model and add to it or remove as you see fit? Let's talk about road visualization, and maybe in a Civil 3D application like this, where we bring that scan into Civil 3D. Right now, this is visualizing that scan inside of Civil 3D. You'll notice that that last view just showed several different locations that were identified inside of that scan. And being able to look at this in 3 dimensions while laying out our alignments, our cross sections or our corridors, all using the scan itself as our base, is of course a much more practical solution than starting from nothing. Now, when we talk about scan and accuracy and control, I love that Joe started this presentation, and the way he started it was saying, why is a surveyor talking about BIM? For every single person on this phone call right now, no matter what stage of your project you work on, no matter what types of projects you work on, every BIM project starts with survey. And when we talk about scans, it's really important to understand what level of detail and what level of accuracy you're getting out of that scan data. What I'm talking about here is being able to consume survey-grade scan data inside of a product like Civil 3D and using that data to design and visualize your project in different ways. What about construction verification? This is a really practical use for scanning. When we talk about as-built, to compare designed models to a scan allows us to do rapid development of as-built checks or construction verification. Whether it's for, of course, HVAC equipment like you see here, or it could be, utilities, or, of course, rudimentary wall layouts, floor placement, stairs, railings, everything. You can compare your scan data to the model itself. Now, one of the last things that I'll talk about with our integration into the product is clash detection. And 2015 products, we now have, especially here for Navisworks, we have the ability to isolate the scan itself based on the clash. So you'll see here as I zoom out a little bit, I've got an object that has clashed with the point cloud, but it's not, instead of saying that single object, let me pause it there. Instead of saying that this single object clashed with the entire cloud, it will isolate the region of that cloud that is an issue. And you can see here by just basically hiding everything else, we can isolate the issue and take a look at that in a lot better detail than we could previously in other releases. This goes to show you that as a company, Autodesk is putting a lot of effort into this technology and how it fits into your workflow. In fact, I'm constantly in front of customers up and down the East Coast, really all over the U.S., and asking them how they're using this technology. And sometimes, frankly, they are not using it the way I intended or thought that, ReCap and Navisworks or Civil 3D or Revit would be used. But it's interesting to learn about how they use the technology so that we can help bring that knowledge back to our developers, and those developers can apply that workflow to something that they're developing in-house here. So I just continue through the same workflow. If you're familiar with Navisworks, what you're seeing here is not uncommon as far as clash detection on other types of objects, but the ability to do this with scan data in 2015 is really impressive and much more functional than previous releases. So structural visualization and verification, maybe of bridges. Of course, we can visualize inside of ReCap itself, but maybe we bring this scan data into a product like Infraworks. Infraworks is one of my personal favorite products to show these days. It's a very exciting infrastructure product that allows us to show the context of our projects in its surroundings. And when we talk about reality capture, isn't that what we're talking about? Is the context of a project in its surroundings? So the ability to integrate the scanned world into a product like Infraworks and see all the context of the surroundings, not just the single object that we happen to be scanning, is, of course, going to add value to your workflows. So before we get into ReCap Photo and my last 1-minute slide, I just want to show, we've got many different areas of different industries here that we can utilize ReCap data and utilize reality capture information, whether that's from a photo or whether that's from scanned, traditional scanned aerial or mobile LiDAR. And we can bring that into, of course, our various different products. But the last thing that I'll talk to you about that's exciting is ReCap 360. Now, ReCap Pro, and ReCap 360, of course, are 3 different offerings. ReCap Pro is absolutely recommended for everyone that is doing their own registration and detailed work on clouds. ReCap 360 allows you to share point clouds via the Autodesk 360 cloud. I know that's a little confusing, I'm talking about 2 different clouds. So via the internet versus anything else. So we can share a cloud that's been developed on our desktop via the internet through ReCap 360. Or we can use ReCap 360 to build from pictures. Now, this is a real, in fact, this gentleman that's flying the octocopter here, it's a GoPro with a Hero 3 camera on it. His name's Dominic. He works here at Autodesk. He did this project. And by flying this drone around this specific battery and taking a bunch of photos, he was able to then drag those photos into Recap 360. Once the project had all been submitted, he was then, able to then go into the Recap model. This is what came out of photos. Now, this is not survey-grade accuracy, but when we talk about starting a project from nothing, don't we all start with photos anyway? Don't we go out to a site and take pictures of that site? Why not take those pictures and make a model out of those pictures? And you can take pictures from a drone like you saw in this video, or you can take them by hand. The idea is that you get the whole scope of, or a big, large portion of the scope of your project in your window of view when you take your pictures. But then you take that same content, just like you've seen in previous videos, you take that same content into a product here like Revit, where we start to lay out geometry inside of Revit. Maybe we cut cross-sections, draw elevations. Maybe we start laying out the new geometry, like here they're doing some mass modeling for an addition, basically, that's going to go on top of this this battery. Now, this isn't a real project, just so you know. This is totally a fake project. A realistic example of what could be done using Recap Photo. Talk about preliminary designs and concepts. This is very accurate, not survey-grade accuracy, but once you add survey-grade accuracy to this data, that's what a BIM project is. It's a life cycle of a project.